Section 2.7, derivatives of sine, cosine, e to the x, and ln x. So in this section, we are going to add 6 more derivatives, and these, honestly, you just have to memorize. Sorry. Some really easy, though. Derivative of sine is cosine. Shockingly. Interesting, huh? So if the derivative of cosine, then, is negative sine. Kind of interesting. So sine is cosine, and cosine is negative sine. Okay. This one's really tough. E to the x is e to the x. That's a sarcasm because it's the same. B to the x, meaning if you have any base to the x power, it's b to the x, just like e to the x, but you have an ln base of the exponent. So that one's a little bit extra than this, but they're very similar. Ln x is 1 over x, and log of any base x is 1 over x with the ln b at the bottom. And what you'll notice is how kind of this and this are similar, or straight up, but the logs with any base have this ln b, and the exponents with any base have an ln b. So you gotta get the natural logs do not have ln b, but the other ones do. The reason for that is if the base is e, ln e is 1. So that's why there is none on this one. Really, it's ln e which disappears. Really, here there's an ln e which disappears. Anywho, so with that said, there's sine, cosine, exponents, and logs. So let's take the derivative of this. So just do it one step at a time. So the derivative of 3 to the x would use this formula right here. So that would be 3 to the x times ln 3. That would be the first piece. Next, minus the derivative of ln x is 1 over x. And we're done. That is your answer. There's really not much to simplify here. I mean, you could do some stuff to simplify it if you want to. I mean, you could technically multiply the front piece by x over x. And when you do that, you get x times 3 to the x, ln 3. And then that would be also a minus 1, all of this over x. So you could do that because, you multiply this by x over x to get a common denominator. So that would also work, but this is perfectly fine. All right, next, this one. So we're going to take the derivative of g and then plug in 0. So let's take the derivative of this. So g prime x is going to be equal to, what's the derivative of e to the x? Derivative of e to the x is e to the x. And what's the derivative of sine x? Well, that is cosine x. All right, so we just took our derivative. So now we are going to plug in 0. All right, let's see what we get here. G prime 0 is equal to e to the 0 plus cosine of 0. So what do those equal to? E to the, well, anything to the 0 is 1, and cosine of 0 is also 1. So what is 1 plus 1? Isn't that equal to 2? So won't the answer to this be 2? Alrighty, let's take this limit. Now hopefully you recognize this as a derivative. Alright, it's gonna, like usual, it's kind of hard to notice it, but this is really just saying the derivative of 3 to the x at 0. So let's write that out. This is saying the derivative of the function 3 to the x when x equals 0. That's all it's saying. So what's the derivative of 3 to the x? Well, that's going to be 3 to the x times ln 3. And now, do we plug in 0? So 3 to the 0 times ln 3. What is 3 to the 0? Isn't that 1? What's 1 times ln 3? Isn't that just ln 3? So my answer here is ln 3. If f of x equals log x, then the limit as x approaches 6 of this equals what? Well, isn't this slope? And if you plug in 6, isn't that divided by 0? Isn't this the same as this? And yes, it is. But the function for f is this. So really, what this is saying is take the derivative of log x for the value x equals 6. So let's do that. what is the derivative of log x? If you look at it, it's right here. So we're going to use this formula right here. So that would equal to 1 over x ln, and the base is, there's no base, so that's base 10. It's, remember that. There's really a 10 hiding right there. That's a tricky one. People forget that. So that's the derivative. But we're going to plug in 6. So won't right here, aren't we going to replace that right there with what? We're going to put 6. So that would be the answer. So my answer is going to be 1 over 6 times ln 10. And voila, the answer. So when you see these weird notations of limits, usually they're talking about derivatives, and you have to be able to see the different type of notations to see the derivative in these situations. Now technically, just so you think back to this one, you might say, well, wait, these look completely different. If you think about this, what is 3 to the 0? Isn't 3 to the 0 1? And for this one, isn't this x minus 0? So really you have f of 0, 0 here. You just have it in a different format. So sometimes it's easier to see, sometimes harder to see. You just got to spot when this derivative is popping up in a limit format. For what values of x on 0 to 3 pi does the function of sine x have a slope of 1? So first time when we say slope of 1, what that means is I'm looking for when my slope equals 1. Another way of saying slope equaling 1 isn't that saying y prime equals 1. Now, what is y prime? Well, y prime, what's the derivative of sine? The derivative of sine is cosine. So wouldn't the derivative of y also equal cosine x? So if the derivative of y is both of these, aren't these equal? So really, aren't we asking for, in this problem, when is cosine x equal to 1 on this interval? Oh, okay, that's what they're looking for. So let's now think of the unit circle and think, where would that be? So let's see, where is the x? Cosine's x equal to 1. Well, it's right here. So it would be at 0, it would be at 2 pi, it would be at 4 pi, and so forth. Those would be the values for when cosine equals 1. Because if you go over here, isn't that negative 1? Here it's 0, and so forth. So it's these values. So which of these values is in this interval? Now 0 is not, because 0 is on the edge of the interval. So the only one in here would be the 2 pi here. So my answer for this problem would be when x equals 2 pi would be the only value for when the slope of sine x is 1.